Today, we are going to start discussing the last topic in our course, which is about files in C. We shall see why we need files in a C program, how they can be created and maintained. So, this is the topic for today. Before looking at an example program using files, we can see why we need files. Consider a program to maintain the information about the students in a class. Suppose we have to write a program which maintains information about the students in a class. Suppose these are the various attributes of a student that the program has to maintain. For each student, it needs the roll number, name, and date of birth. And suppose you have a program and the program maintains this data as an array of structure elements. Actually, that is what we did when we discussed that programming exercise. So, you created an array of structure elements to maintain the data of students in a class. And also assume that the user, so you as a user, has given input details. You have entered details of all the say 70 students in your class. So, what will happen? So, you have spent a lot of time in giving the roll number, name, and date of birth of all the students in your class. And without using files, you did it. So, what will happen? Enter data in the array, that is data of all the 70 students, will be lost when the function or program terminates. Why? Because if your array storing the details about students is local in a function say foo, then the memory allocated to the array will be deallocated or taken back when the foo instance finishes its execution. This is what we have seen. This is an automatic array. So, the moment the function terminates and control goes back to the calling function, that array will be taken out from the memory. So, the data will be lost. And the only other possibility is you can declare the array as a global array or a static array. In that case, memory allocated to the array will be deallocated or taken back when the program finishes its execution. For global or static data objects, the lifetime is only throughout the execution of the function, and that is why I said the entire data that you stored in your array will be lost when the program or the function terminates. And this is not what you need, because when that program is executed next time by the same user, the entire data need to be supplied again, which is not what we need. We need a way by which the data can be stored permanently in the memory, so that later when that program is executed, the data can be accessed and processed or modified, etc. So, we need a language feature to store data permanently in the secondary storage of the computer. So, when you are creating an array or any data object, you are actually getting memory allocated in the RAM, which is not a permanent data storage. The data will be lost in the case of a C program the moment you finish executing your function or program. and C provides a language construct known as file for permanent data storage. And a C program can use files to store and process data on permanent storage. So what we saw is that when we need a program which needs to maintain a large amount of data which can be entered once and processed whenever you execute your program, then you need to store that data permanently on the computer memory, which is called the secondary memory of the computer. And in that case, you must have to use what are called files. And now we are going to see an example program which creates a file and writes a text data into it. Okay, so what we are going to discuss now is about data files in C. Now you can see a program using a file for permanently storing data. First we will look at the architecture, then how will it look like, the program which is accessing a file in secondary storage. So you have a program and you have your secondary storage, maybe the hard disk, or maybe even you can use any other external storage like USB storage, etc. So storage, when I say storage, I mean the secondary memory, which is a permanent storage device, not the primary memory like random access memory, which the program directly operates on. A program can use a data file to permanently store data on storage. So data file is the programming construct which enables you to store data permanently on the storage. These are the stages through which file F goes during its life cycle. Initially it is non-existent, the file has not been created, then you will create it, the file is existent, then you can process it, and finally if you want you can delete it, then it will go to non-existent state again. If you look at it in terms of the storage, assume that you don't have a file in the storage, and using C program and a function call, you can create a file. So in the storage you are creating a file, namely F, and then the state becomes existent. Now you can process that file any number of times, maybe you are adding data to it, or you are modifying a data in an existing file, or you can maybe append data, whatever. We will discuss about various processings, and if you want, finally you can delete that file. Deleting means from the storage you are taking it out. So these are the various states through which a file can go. So we said the program can write directly into storage, but this is not how exactly this is happening when you run a C program. A C program cannot directly write or read from the secondary storage. So whatever a C program is accessing from memory, it must be in the main memory of the computer. A program during execution can access only the main memory, and here suppose we have RAM, random access memory, as main. So in order to implement the data transfer between your program and the secondary storage, actually an intermediate memory is used to temporarily halt data in transit between program and storage, and which is what is called a buffer, which is a part of your random access memory, which is allocated to temporarily halt data when you are transferring data between your program and storage. So buffer is an intermediate storage in random access memory to store data temporarily. and program reads from and writes to the buffer. The commands or functions that you are going to see operates on the buffer, not directly on the storage. So when you say you write a character into the file, you are actually writing into the buffer in the random access memory. Or if you are saying read the next character from the file, actually the system will prefetch the data from the file and make it available here, and you can access that data through your program. And the data transfer between the buffer and the storage is taking place automatically, that you are not aware of, your program is not aware of. The system will automatically do it. If you write say 10 letters to the buffer, you don't have to worry about this transfer, that will happen automatically. The runtime environment will do it. And for you to create files or access files, what the C language provides is a system defined structure, namely file, which can be used to access a buffer, to create and access a buffer. Okay, and we will see examples, and you can in fact create a pointer of this structure variable to which you can open a file or create a file. So now we can see what is that structure file which is provided by the C language. Actually, structure contains basic information that you need to access the buffer. Buffer is the temporary data storage in the RAM to which you can write data or from which you can read data, and this is actually representing the file on the storage. And for that you need a number of fields in the structure, which includes the index to the next character in the buffer. You can view it like a single dimensional array of characters, you can say. You can view it like that. And so there is an index which shows what is the next character in this file, okay, which actually is in the buffer. And it also contains a field which shows the number of characters available in the buffer. Maybe 1000 characters are there, then it shows 1000 as its value. Another field which is a pointer to the base address of the buffer. If you view it as a single dimensional array, it is a starting location address. And it also contains a field which shows whether the end of file has reached or not. Every file will be having a special character which is called end of file, which delimits the file content, that is the last part of the file. And it also contains access permissions, etc. Maybe whether you are able to only read, or you can also write, or you can append, etc. So these are the various fields, the common fields that we will be using in our programs. Now we can look at a concrete example which creates a text file and stores a string on that text file. So here is the example program. You have a program and the function foo creates a file, file1.txt, and it writes a data into it. So now you don't have a file, that is the assumption on the storage, and see that to operate on a file, the first thing that you have to do in your program is you create a pointer variable of this system defined structure. Not that it is a system defined structure file. You can create a pointer to that, and actually to that pointer you will get the address of the first byte in the buffer. Okay, you are accessing that buffer. In between you will be having a buffer on random access memory, and the starting address of that buffer needs to be collected to this pointer variable. And for that you need this function. fopen is a function provided by the C language, and and this statement is to create a file with the name file1.txt. There are two arguments. We will see it later formally what it is. The first argument should be the file name, and here actually this statement enables you to create a file if it is non-existent, and namely file1.txt. So if you execute this, you will get the file created on the secondary storage. You are getting it? Name is file1. And what is the next statement here? You are printing a message on the screen. Enter a line of text. If you execute, and before that, suppose you expand this will look like this. Okay, if assume that you are opening it in a text processing application, it will look like this. You just have created a file, but no content is there. Okay, and now if you execute this statement, you will get that message displayed, and now you are coming to this part of the function. What is it? It is a loop. You are reading a character until the character read is the new line character. That is, until the user presses the enter key, you are reading character one by one. And after that, what you are doing? You are calling a function called putC, which is put character, which is a function to store a character to the next position in the buffer. Actually, you are storing it to the, you want to store it to the file, but in fact this function is writing it to the buffer in the next position. Okay, and we shall see the syntax formally later. You are saying that this character needs to be written into the buffer represented by this pointer variable. And now suppose the user gives this as the input. This is a sample text file and enter key is pressed. So until this enter key is pressed, every character is taken into C and which is written onto the buffer and which will automatically get stored in the file. So if you execute this part of the program in this loop, you are writing exactly this input into the file. So the file is created, and now a line of text is entered into the file. And finally, you are closing it. Now you have opened it. Okay. Now closing it means it's actually getting stored inside the permanent storage device. Okay. And the file gets stored permanently in the storage, which can be accessed at any time through a C program or by using a file processing application. So now we have seen an example program, a function foo, which creates a file, file1.txt. There is a function called for that, namely fopen. It creates a file, then it writes a line of text and finally closing it. So after that, the file is existing in the in the permanent storage, and later at a later point of time you can access that file. You can read or write or modify, etc., either using a C program, or you can directly open it in a text processing application. Just open it. You can open C and you can modify if you want. So this is what we discussed, and now we can see how will you read a text file and access data from it. And suppose that you have a text file, namely file1. Suppose this is the content. The previous content is this if you want. Suppose we are going to now use a program to read this text file and display it on the screen. This is what I am trying to explain. So in that program, you know that the first operation is again creating a pointer to hold the address of the buffer, and here you can see that I am opening the same file, but now in the read mode. The second argument is actually the mode of operation, whether it is to write into or just read. So now you are reading that existing file, this file, in the read only mode. Okay. Now after that, what you do, you are trying to display a message, file1.txt contains then a new line character. So this is what is happening, and now you are coming to this part of the function where in an infinite loop, while one in an infinite loop you are trying to read the next character from the buffer. What is it? It's a statement to read a character from the next position in the buffer. Note that when you are accessing a file, you are doing it from the buffer, and the buffer and storage data transfer automatically happens. So you can see that you are getting it from the buffer. Okay. Now after that, you are checking whether the end of file has reached or not. Until it, here is the end of file in this case, the last character is here. So this is the end of file. So if the end of file has reached, so you just call this file end of file of pointer variable, it will return yes if the end of file is reached. If that is the case, you break out from the loop. Otherwise, what you do, you print the red character on the screen. So if you execute this, what will happen is this content of the file will be displayed like this. And finally you are closing it. Closing means the file will be closed and is again remaining in the secondary storage. Now maybe we can look at the basic sequence of actions that you need to process a file. And assume that you already have a file existing in the memory, secondary storage, which is called file I. The first operation that you have to do is open that file. Okay, you have to give the file name and the mode of operation, whether you are going to read or write or append. Then you can do any number of processing on it. Okay, once you open, you can do all processing that you need. We will discuss about each of these function calls in the next two lectures. Okay, you can process it. Maybe you can add characters to it, you can add data, or you can delete data, you can modify data, whatever you want. Okay, and finally you have to close it. Okay, this is the basic sequence of operations that you can have on a file. You open it, okay, then you process it, you can add or delete or modify, or finally close it. That is what you can do. Now we have seen the fopen function call. We are going to formally look at what it is. So this is the syntax. What is it? In the LHS of the assignment operator, you have the pointer to a variable of type file, which is actually getting the address of the buffer in the RAM. This is the name of the function. Okay, and next is the file name, which file you want to open, and finally here you have to provide the access type within double quotes, whether you are going to write or read or append. There are different file processing modes that we will see after this in this lecture itself. And not that if the file is non-existent, the same function can be used to create that file. What you do is you can just provide the access type as W. Then if the file is existing, the file will be opened for modification, and if the file is non-existent, a new file with the same name as this will be created. Okay, so this is what we have seen. This is the syntax, and this function returns a pointer to the buffer on the RAM if it succeeds in opening the file for the requested access type, that is read or write. And suppose it fails to open that file for the requested access type. For example, suppose you tried opening a file for reading which is non-existent, then null will be returned by this function call. Okay, so you have to be careful when you are using fopen, because if it returns null and you are going to access it, then your program will crash. So an advice is, when you create or open a file, you do it always like this. you take it into a pointer and immediately after that you check whether you got the buffer created or not. Okay, if it is not created, you are getting null as return value, then you immediately display this message, cannot create the file, and you stop running that function, you return. So this is an advisable way of processing a file. So whenever you open a file, immediately after that you do the sanity check, and if the file is not created or opened, you display a proper message and you stop executing that function or program. Okay. Now we are coming to the last part of this lecture, where we are going to discuss about which are the possible access modes or types that you have to give as the second argument to the fopen function. So it's here, there are various modes. R means read only, W means write only, A means append. That means a file is existing, if you write a character, it will go ask the first character after the existing content. Okay, that is append, and combination is there, R plus read and write, W plus again read and write, A plus is read and append. So in your programming lab, you exercise all these things and see what is the difference between these file processing modes. So today we have looked at the need for using files in a C program, and we also have seen an example program which creates a file and writes a text into it. We have also discussed another example which opens an existing file and displays its content. And we have also discussed about the basic sequence of operations on an existing file, which is to open it first, then you process it in the way you want in your program, and finally close it. In the next class, we shall discuss about various operations which you can do on files using a C program. Thank you.